In this video, we're going to be dividing polynomials. There are many different ways to do it. This is only one way. We're going to be using long division to do it. So real quick, I just want to review long division because it kind of applies. There's a lot of steps that are very similar. So we are always asking ourselves what this number on the outside, how many times does it go in to the numbers on the inside, right? So we ask ourselves, how many times does 8 go into 1? Well, that doesn't happen. So we don't have to put anything, or you can put a placeholder there. How many times does 8 go into 10? We move over, right? So only one time, right? And then what do we do with that number? We multiply. We multiply this number by this number, and we subtract it from this number, right? So 1 times 8, and we subtract. That process is what we're going to be doing when we're dividing polynomials. So we do the subtraction, we get 2, and then we drop the next number down. Again, same thing we're going to be doing in a sec here. Then start the process over. How many times does 8 go into 29 without going over? Well, 3 times. Multiply this number by this number and subtract. So we end up getting 5 there. We're going to drop the next number down. And we ask ourselves, how many times does 8 go into 55? Let's see, 6 times, 7's too many. So again, we multiply the number up here by this number, write it down here, and subtract. So here we get to the end. We got, what, 7 left over? There's no more numbers to drop down. We've reached the end here. This is usually called the remainder. And one way that maybe you've never seen it written before is as a fraction, or remainder as a fraction out of 8. Since we're dividing by 8, well, that's our denominator, right? And our leftover is always the numerator. So it's 136 and 7/8. We're going to think about this as well when dividing polynomials. So let's get into it here. Just think about that process. If I want to divide, let's try x plus 6. There's a polynomial. Let's see how many times it goes into 2x squared plus 13x minus 7. Alright, so one thing we always want to check to make sure of, and I'll repeat this again later on when we have a better example, but you always want to make sure that this number under the division sign is in order of powers. So we got a x squared, we have an x to the first, and we have a constant. So since we have all of our terms in descending order, we don't have to do anything. We're going to see an example in a few minutes where we might have to do something with that. So we're allowed to just move on. What we're going to divide each of these terms by is the term with the highest power here on the left. So because it's only x to the first and we don't have anything higher than that, what I'm constantly looking at is how many times does x go into all of these terms. And where 6 comes into play is a little bit later on. So let's ask ourselves, how many times does x go into 2x squared? And sometimes you can even write it over to the side if it helps. So we're looking at that division, that quotient. So it goes in 2x times, right? So we put that above our x to the first power here. So we're always matching up powers here. Now, this is where the plus 6 comes into play. Remember, we multiply what we got on top by what we got over here and subtract. So we're going to do the same thing. 2x times x is 2x squared. And 2x times positive 6 here is plus 12x. And we're going to subtract it. So if we're subtracting this binomial or polynomial, whatever it is, we want to make sure and distribute that negative sign to all of our terms here. So this first term is going to be negative, and this next term is also going to be negative, right? So when I do 2x squared minus 2x squared, I get 0. When I subtract 13x minus 12x, I get 1x. Okay, we bring our next number down. So now we have 1x minus 7. We repeat the process. How many times does x go into 1x? So we need to write that. Well, hopefully it's pretty obvious. 1 time, right? Positive 1. And then again, we multiply our number up top by everything over here, so we get x plus 6, and we're subtracting that. So we make sure that everything's the opposite of what it is. So 1x minus x gives us 0. A negative 7 minus 6 would give us a negative 13. Since we're done over here, we have no more numbers to drop down. We're done with our division here. This must be our remainder. So we write negative 13 is left over what we're dividing by, x plus 6. So let me rewrite the answer just so it's super clear here. We got 2x plus 1 with a remainder of negative 13 over x plus 6. So strange little answers we get when dividing polynomials. This is our remainder, it's what's left over. It went in 2x plus 1 whole times, and then it had a little remainder afterwards. Alright, so maybe this is quite a crazy process, but if you practice it enough times, it's pretty easy. Let's do another one. Let's do x minus 1, see how many times that goes into x to the third minus x squared minus 2x plus 8. So again, make sure that the number we're dividing into, this number right here, this polynomial, all of its powers are in order. So we got x to the third, x squared, x to the first, and a constant. We're not missing any terms. We can just go ahead and divide like we just did. Again, we're always looking over here at the term with the highest power. X to the first is it. So I divide each of these terms by that x. So x to the third is our first term. If we divide by x, then we get x squared, and we write that above our other x squared. We then multiply and subtract. So x squared times x is x to the third. Negative 1 times x squared is negative x squared. So we're subtracting that, so make sure you distribute. This ends up being positive now, right? So x to the third minus x to the third would be 0. Negative x squared plus x squared, well, that would be 0 as well. And so we drop it down. The next number is negative 2x. Let me get rid of these zeros in case they're confusing. So now we ask ourselves, how many times does x fit into negative 2x? So negative 2x divided by x, well, negative 2 times, right? So negative 2. Multiply this by this, so negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. So then we got, we got to subtract, right? So this becomes positive 2x, so those will cancel. And then we got a negative 2. Well, if you drop this term down, we could do it. We could drop the 2 down right here and then drop the 8 down, but that's a little confusing. Let's just keep it all linear here. So 8 minus 2 would give us 6. Since x can't go into that any amount of times, that ends up being our leftovers or our remainder. So our answer ends up being x squared minus 2 with a remainder of positive 6. Sometimes they put a plus there. Over our quotient x minus 1. There we go. Alright, again, you know, checking division problems, we could always multiply this by this and see if we get back to the beginning. I'm not going to do that in this video. You're more than welcome to try it, see how it works. Let's try another problem here. Here we go, a little crazier now. Alright, so like I was talking about earlier, I left this blank because I don't want to erase and rewrite something, but if this was our polynomial, y to the fourth plus 2y squared minus y plus 5, you notice that we're missing a power. We're missing that third power, right? So anytime you have a division problem where you're missing one of those powers, you want to place a 0 in its spot. So we're going to say 0 y to the third in its place. And the reason why is because when we're doing the math, we need that placeholder. So let's see how it works out here. If you don't do it, you end up getting stuck, and you're probably going to be confused as to why. So if you're missing a power, always add that 0 coefficient there, and then everything should work out nicely. So again, over on the left, we're looking for our variable with the highest power. That would be y squared. So we're going to see how many times y squared fits into all of these terms here. So our first term is y to the fourth, and we're seeing how many times y squared fits in. Well, that's y squared times. So we write that over the y squared. And multiply this by everything over here. So y squared times y squared is y to the fourth. Negative y times y squared is negative y to the third, and there it is. If we were missing that y to the third here, we wouldn't be able to subtract this from anything, and then you end up getting stuck. So that's why we need that placeholder there. Keep multiplying. Positive 1 times y squared is plus y squared. So remember, we're subtracting this, so everything needs to be the opposite of what it is. Y to the fourth minus y to the fourth would give us 0. 0y to the third minus 1y to the third would give us, oops, it's a positive, right, when we distribute the negative. So we get a positive y to the third. And over here we're subtracting y squared. So 2y squared minus 1y squared. Sometimes you might have to add that invisible 1 there just to help you with the math. So we get a positive y squared. We don't have to bring anything down because this is all divisible. So we ask ourselves, how many times does y squared fit into y cubed? Well, just y times, positive y times. So multiply and subtract. We get y to the third minus y squared plus y. You could drop this down, seeing as how we're going to have to subtract it from a y, so we got a negative y there. If we subtract this all, well, that cancels. That's good. Here we have a positive y squared and a positive y squared. Well, they each have 1 as a coefficient, so we got 2y squared. And right here we got, remember this is negative if we distribute it right here. So we got negative 2y's. Alright, again, 2y squared. And we're seeing how many times y squared goes in. Well, it only goes in twice, right? So then multiply and subtract. We get 2y squared minus 2y plus 2. Drop this guy down for that subtraction. And we're beginning to run out of room. Let's see if we can fit it here. This cancels, right? Here we have a positive 2y and a negative 2y. That cancels. And we just are left with 5 minus 2, which is 3. And that ends up being our remainder. So we got a remainder of 3 over this entire thing right there. That's our divisor. So that's got to be our denominator. So there's our answer. It's kind of small to see, but that's it. So that's dividing polynomials using long division. There are other techniques. We may get into those in a later video. All right, good luck using long division in dividing polynomials.